categories, ranging from no problems, then slight problems, moderate problems, severe problems, or extreme or unable to. And these responses are coded such that the higher level or higher response option means a greater amount of problems in that dimension. So the EQ5D instruments are the most widely used in assessing health-related quality of life for use in cost-effectiveness analysis. That's where you primarily see these utilized. So why did we switch over from the EQ5D 3L to the 5L? So there's a bit of history lesson here. The EQ5D 5L was introduced in 2009, and it's really to improve upon the shortcomings that were noted with the 3L. So the 5L offers greater descriptive richness. You have more health states, 3,125 possible health states that can be described by introducing these 5 response levels instead of 3. And additionally, the 5L is noted to have reduced ceiling effects, which is concentration of responses at that no problems level. Some of these features, though, may not be as relevant when we're thinking about the EQ5D in one of its other uses, which is measuring population health, where there's a higher proportion of healthy people with few or no problems in these dimensions. And again, the development of this instrument was largely driven by a desire to increase precision for estimating utility values and qualities for use in cost-effectiveness analysis, especially in these more specified ill populations. So it differs from measuring health within a healthy, kind of just average population. So this represents maybe more of a gray area as to whether there's an expansion, this expansion was necessary in the context of evaluating population health, and perhaps 3 levels is sufficient, or perhaps something like 4 levels could be considered. So to that end, I just want to specify one more thing, actually. Why this is important is because for any measure, you want to maximize the amount of information you get, but minimize the amount of respondent burden or potential confusion that could result from answering that measure. So this is important because if there's too many response levels that aren't being used, that's added burden on the respondents and added sources of potential error when you're analyzing your results. So to that end, the primary aim of this study then was to examine the usefulness of 5 levels of response of the EQ5D in measuring population health, especially in terms of scale efficiency. And again, this was done in a general adult U.S. population. And then we also evaluated other variations in the number of the response levels. So beyond just 5 levels, you'll see what other variations in these numbers that we came up with. So I'll talk a bit more about what that means by scale efficiency in a few moments here. But first, I just want to reiterate where this data was coming from and the data source. So as was mentioned, this was data from the 2017 U.S. valuation study of the EQ5D-5L. You can find the comprehensive methods of that study already published. It was published by Picard and colleagues in 2019 in Value and Health. So I'll just kind of hit the highlights of the methods that are most pertinent to the work that we did here. So in that study, adult respondents across 7 cities in main U.S. census regions were quota sampled based on gender, age, race, and ethnicity categories to ensure a sample that was representative of the U.S. population in these characteristics. Eligible participants completed several interviewer-assisted tasks. And then in addition to the in-person recruitment, which we have the pictures of here, there's also an arm of participants that completed valuation tasks independently online. So in-person and online total. So the main purpose of the valuation study was to assess health preferences of the adult public to produce a value set that could be used in economic evaluations and other health technology assessment applications. But in addition to the time trade-off tasks, which you see up above, and the discrete choice experiment tasks that these were used to assess those preferences, participants also self-rated their health on the day of these interviews or of these tasks using a few different EQ5D measures or instruments. So here, one example, they self-rated their health with the EQ5D5L, as well as the EQ5D3L, which I showed earlier. So for example, if a participant was feeling great that day and had no problems in any dimension, they could have said that they had no problems across the board, and they were coded as 1, 1, 1, 1, 1. So 5 ones to indicate their health state. Another instrument that participants used to rate their health was the EQ-VAS, which stands for the Visual Analog Scale, which is a rating scale where participants rate their overall health that day from 0, which is their worst imaginable health, to 100, which is the best health that they could imagine. And again, this is their overall health, and this is a common element in EQ5D instruments. But what was interesting is, as a twist, as like an experimental element, we also had participants self-rate their health using a visual analog scale specific to each of the 5 dimensions. So for example, here I'm showing mobility. Instead of rating their overall health that day, they also considered just their mobility from 0 to 100, where 0 represents unable to walk about, and 100 would be no problems in walking about. And again, this is just mobility here, but they also did that for the other dimensions: self-care, usual activities, pain, discomfort, and anxiety, depression. So there's a few important things to note about this little twist that we introduced. First, notice that the VAS tasks here are anchored using the same descriptions as the EQ5D5L. So the level 1 description, no problems walking about, all the way down to the level 5 description, unable to walk about. And then you may notice then that unlike the EQ5D, in this VAS, having a higher score on the VAS indicates fewer problems with that dimension, and it's opposite in the EQ5D. So just keep that in mind. So basically what this allowed us to do then is we had information from participants where they rated their health using the EQ5D5L as well as the EQ-VAS for each dimension. So what we could really do is take advantage of having this more granular 101-point scale and see how they anchored their health specifically related to the levels 2 through 4 of the EQ5D, since levels 1 and 5 are already represented here. So essentially we could see how they sort of calibrated those levels 2, 3, and 4 somewhere along this scale. And we'll get into more of that in a moment, but I want to just kind of show what we did in words then. Is for the EQ5D5L, we calculated mean VAS ratings for each level of each dimension. And then we calculated the difference in the VAS ratings between each of those adjacent levels. So for example, between level 1 and 2, or between level 2 and 3. And then we also did something of where we combined the level 4 and 5 responses, so those severe and extreme problems labels, to examine this same sort of information on a 4-level EQ5D scale. So in essence, we had information from participants where they've rated their health on 4 different scales. So one is the EQ5D 101 level VAS, where they rated their mobility and the other 4 dimensions from 0 to 100, as well as the EQ5D3L, the EQ5D5L, and though they didn't specifically rate the EQ5D4L on their own, it's something we created by combining the 4 and 5 level responses of the EQ5D5L. So throughout, you may see 101, 3, 5, and 4, and that's what those are referring to, are these different scales that they used. So another thing that we did was to characterize the so-called descriptive richness of each of these variations in the number of response levels using something that are called Shannon indices, which I'll explain in a few moments here. It's not something that I had encountered, but hopefully we can all learn to appreciate what they represent. Okay, so Shannon indices, which you may also see referred to as Shannon-Weiner or Shannon-Weaver indices to credit other foundational creators, were originally described in 1948 as a mathematical way of differentiating useful information from noise in telecommunications systems. So within this kind of field of information theory, this informativity is dependent on the number of classes or the number of response options you have, but as well as the distribution of observations, which could be considered like a signal in telecommunications, among those different response options or classes. So this has been adapted into a number of different fields. Most notably, you may see ecology experiments using this as a measure of biodiversity. But they've also become more widely adopted and utilized when talking about health measures. So, for example, Janssen and colleagues here said that Shannon indices are well suited to assess discriminatory power of multi-attribute utility instruments like the EQ5D because they consider not just the floor or ceiling effects, the extreme response categories, but also any response category in between. It's really considering the whole system, the number of response options, and how respondents are distributing themselves within those response options. And here's just another example of these indices being used in more recent publication in this field related to the EQ5D. So this was from February 2022. And this is just a little teaser. I see it's a little cut off on the screen here of what the equations are, but I will show them in the next slide. So what are these actual indices? Let's go through the equations, and hopefully I can explain these a little bit more. So the main Shannon's index, which is denoted as H prime, it measures the absolute informativity or the distribution of respondents to available response levels, if we're thinking of like a measure. It's the sum of the proportion of respondents that selected a particular response level and then summed up across the total number of those response levels. The higher the value you get of H prime, the more information that's captured by that system. And H prime can increase with the number of response levels, so adding more response levels to your measure, let's say, will increase H prime, but only if those response levels are actually utilized. If you have a bunch of empty response levels, that actually won't impact the H prime. However, the max H prime is actually related to your number of response levels. To account for the fact that you could have a lot of empty response options, there's the Shannon's evenness index, which is related by J prime, which accounts for the fact that there could, or which accounts for H prime with the number of possible response levels, or dividing H prime by H prime max. So it's all pretty confusing. Hopefully this picture can help. So let's walk through this. So in figure A, we have a skewed distribution and compared to a more rectangular distribution. And we can see both have 3 levels. And H prime is maximized when you have even distribution of respondents among those response levels. This also means that your J prime, or the evenness index, is 1, which is its maximum value, representing a completely rectangular distribution. And you can see that the J prime is lower in the skewed distribution. That's how these function. Looking at B, figure B, we can see that now we're comparing a 3-level system to a 5-level system. In this case, 2 of these response options are not utilized at all. So H prime is the same in each of these. But J prime is actually lower because it's taking into account that there could have been responses in these additional levels. So then why don't we just use J prime all the time? Because if we are comparing 2 rectangular distributions, both of these have J prime equal to 1.0. They're both evenly distributed. But we actually see that we get a more absolute informativity represented by H prime when we have these 5 levels compared to the 3 levels. So in other words, you can get more information from including response levels if those response levels are actually used. So hopefully that helps clear things up. I'm going to pause on this picture for you to soak it in while I take a drink of water. Okay. So what we did is we calculated H prime and J prime for each of those 4 variations of the EQ5D scales. So I will present those results in a moment, but first let's take a look at just some of our respondent characteristics. So overall, we had 3,151 respondents. 1,133 of those occurred face-to-face, and 2,018 were done online. And here's some of the notable characteristics. Again, we did quota sampling for everything that's in this box to the left. These age categories, gender categories, race, and ethnicity categories. And then I just pulled out some other information about our respondents that may be of interest. Note that really the point of this is that, this was, just to reiterate, that this was a general kind of adult public sample. They were recruited through things like recruiting off the street or in coffee shops, through word of mouth, as well as through Research Match, which is a website that can link studies with participants. So note that this wasn't really a patient perspective. This is just an adult public perspective rating their health. And as such, we see that in reflected in the way that respondents self-rated their health. So here I'm presenting 2 of the dimensions that we looked at, mobility and anxiety and depression. So on the left, you see the EQ5D 5L response levels, and here's the number of respondents that selected each of those levels. So right off the bat, you could just notice that the number of respondents that had no or slight problems in each of these 2 dimensions predominated over the other levels. And then what we did was looked at the corresponding VAS, average VAS, for each of those response levels for each dimension. So as you can see, as the, like for example, in this mobility, for the average person, or the average for people that selected that they had no problems walking around, the VAS rating was on average 96.2. And then it goes down as people indicated that they had more problems. However, if you look at levels 4 and 5, you can actually see that the mean VAS is actually higher for those that selected level 5, meaning that they're unable to walk, compared to those that selected that they had severe problems walking. And if we're looking at like the difference between each of those response levels, we see that then that results in a negative difference, indicating that this 5th response level was actually higher than the 4th response level. So something a little peculiar. When we actually combine the 4th and 5th response levels together, we get something that's more consistent with the degree of VAS ratings between each of those other response categories. And those differences between response categories, because again, I'm only showing 2 of the dimensions here, but across all dimensions ranged between approximately 12 and 20. So that kind of indicates how people self-calibrated along the VAS when also completing the EQ5D5L. So the trend that you're seeing with mobility with this strange negative difference was also observed with self-care and usual activities, and then it was a very small difference with pain and discomfort. Only in the anxiety, depression, which is why I'm showing it here, was there a more consistent difference between each of those levels. And there's actually a sort of what you'd expect of having extreme problems be less than severe problems. And partly this might be due to the fact that this was the only dimension in which there's actually a sizable proportion of people that actually indicated that they had problems in this area. So then another kind of interesting thing is that when we looked at the mean VAS rating by level averaged across all 5 of the dimensions, we see that there's this approximately 16-point difference between levels 1, 2, 3, and 4, but almost no difference between levels 4 and 5 when we average those together. And again, if we're looking at combining the level 4 and 5 responses, we see that there's sort of this, consistent 16-point difference. I think it's a little interesting that it ends up being around the same level of degradation for each level. That could just be due to numbers working the way they do. It may not actually reflect that this is a consistent element of the system. And then I think another notable thing about this result is just remember that the level 1 and the level 5 descriptors were used to anchor those VAS elements. So technically, if you selected level 5 on the EQ5D, your VAS score should be 0 to be consistent. So we see a bit more consistency with these level 1 responses. They're close to 100 as we'd expect, but they were only really using kind of half of this VAS scale when you're considering this calibration that we're thinking about. And this all relates back to those Shannon indices, because there's this idea that, we have all of these different response levels, but how many of them were actually utilized? And again, for something like 101 response levels, as we offered in the VAS, that increases your H prime a lot because there are just so many more response levels. And even if not all of them are utilized, still enough of them are utilized to really drive up this value. So this is as expected. This H prime should indicate that we're getting a lot of information from this 101 level response system. But perhaps it's more fair then to look at the J prime, which accounts for the different number of levels for each of these systems. And the most notable thing here is that when we combined those 4th and 5th level systems to create this 4L system, we saw an increase in the J prime, or the increase in that descriptive efficiency, at only a small decrease in H prime, kind of accounting for that reduction in one level. And for some of these, such as mobility, self-care, and usual activities, we see that the 5L, or the EQ5D5 level system, had actually the worst descriptive efficiency compared to some of these other systems, such as the 4L or the 3L. So we can look at that kind of graphically again. H prime should be greatest across all dimensions for this 101 level system. And then we saw that the 4-level system combining the 4th and 5th level of the EQ5D5L resulted in a increase in the statistical, or in the descriptive efficiency, at a small decrease in the H prime value, the kind of total informativity of those scales. So there's two kind of key takeaways from looking at this. One is that these U.S. general population respondents had poor differentiation between levels 4 and 5 when we presented them with the opportunity to anchor independently on this VAS scale that was also dimension specific. Except for in the anxiety depression, we actually saw that respondents utilized more of those response categories of the EQ5D5L and had a more consistent degradation in their anxiety depression rated on the VAS. And then thinking about this concept of descriptive efficiency and informativity compared to the 5L or 3L, the 4-level system may be most optimal when considering this trade-off of having more information, but also having a more efficient system. So there's a few caveats to all of this. I've sprinkled a few of them in, but I want to focus on a few kind of main discussion points here that can really help to add more context and explain what we're seeing here. So number one is that the labels of the EQ5D5L are not perfect, and there's already research out there that says that some people, some respondents might actually flip around the level 4 and level 5 descriptions. Again, that's our severe and extreme, and they may not understand quite what is meant by severe versus extreme and may think one is actually more or is worse than the other or indicates worse health than the other. And, you know, some of this may have been mitigated in a face-to-face interviewer-assisted task where respondents could ask questions like that, but not necessarily when completed independently online. So in some ways, you know, we are aware of this fact. As you can see, Dr. Picard is an author on this study here. So this was sort of part of the theoretical basis to justify combining the 4th and 5th level responses. So more crucially and harder to rectify is the fact that this was a general population of ambulatory adults out in the world that had no or few health problems. So we had low numbers of responses in these 4th and 5th categories. We weren't recruiting in the hospital or at clinics or places where you would encounter, where you'd be more likely to encounter patients or things like that. So keep in mind also that this 4-level system was something that we created by combining 4 and 5-level responses. It wasn't something that the participants actually completed themselves. They only completed the 3L, the 5L, and that 101 level VAS. So in terms of potentially moving forward with this work, kind of some remaining questions or potential directions to move forward include, are there other ways to characterize this informativity? We use these Shannon indices because they're popular in applications of the EQ5D and health measures, but maybe it's worth looking at other methods that could be extracted from this field of information theory. And another question is, have other researchers implemented this kind of experimental VAS 101 level system that we could compare across country to see if these are generalizable or if these results kind of hold true in other settings. And then the other thing that we could do with data that we already have is do some kind of known groups comparison among the respondents that we have. So respondents self-reported their experiences with select illnesses, but that was asked over their lifetime. In general, have they experienced illness like depression or MI or something like that? Whereas these EQ5D health rating elements were considered just for that day. So there may be some difficulty in selecting those as anchors for some kind of known groups comparison. But what we do have is the standard VAS element, which again asks participants to rate their health, overall health, from 0 to 100, not just dimension specific, but just overall. So potentially we could use that use some kind of cutoff along the VAS as a way to create separate groups of those that were more ill versus those that were more healthy. Again, overall, we saw that most of our respondents were quite healthy with no problems or only mild problems. But if we did this kind of breakdown by group, maybe we could remove some of these averaging effects of having this predominance of healthy people mixed with this group of ill people. And we could see how the calibration with the VAS differed between these two different groups, as well as calculating the Shannon indices. So potential future directions, and yeah, maybe I will be presenting this, like I said, at other venues, hopefully collect some ideas moving forward and potentially make this work publishable with future analyses or something like that. But for now, I just want to thank everybody for their attention and open things up for questions. I have lots of questions. Okay. Students first, Carter.
I get a feeling I have an easier question than the rest of them, but we all have to make them easy. That's a condition of John's birthday. Well, mine's actually going to be easy. Okay. So I'm just wondering, like, is there any thought, and I know this was the same question a little bit ago, but like, was there any thought to further investigate why people are rating, unable to walk as a health state at 40, as opposed to like something closer to 0? Because because as you were saying, like, it seems like they're only using half the scale somewhat, and it'd be interesting to me to try and understand why someone would say, like, I'm unable to walk, but yet I rate my mobility health at 40. So is there any thoughts about, like, ways to investigate that, or thoughts about future investigation of that issue?
You have to repeat that.
Okay.
And then I'm going to turn on the ceiling mics.
Okay.
If they're not. Are they on?
So
you repeat it once the ceiling mics are on.
I'll repeat it. It's okay.
Ceiling mics are on now, but John can repeat.
Okay, so I'll repeat Carter's question. He was asking, is there any thought for why participants may have rated their health as unable to walk, but then the average for the VAS ended up being around 40-something, when in fact the anchor for unable to walk should be at 0. My thought on this is that these were elements that were introduced. They weren't given together to participants to complete. They're done at different times during this overall evaluation task interviews. So it's not like they were back to back and there was maybe some level of consistency. Participants may not have realized that these were kind of anchored along the same things, even though they're using the same description. So I think, yeah, it's just a fact from that. Todd.
Yeah, so I was not surprised that there was some end of scale aversion for the walking domain, right? Like unable to walk could mean I'm restricted to a wheelchair. Whereas when I'm looking at it in my descriptive system, unable to walk might mean to me that I just can't walk around much, right? So I'm not super surprised that there was this end of scale aversion for that particular domain. That wasn't my question.
You just wanted to hate on my question.
No. I just wanted to make an observation. Not my intent, just my personal viewpoint on this. My question has to do with Dr. Shannon's measures that I'd never heard of before, so I learned something new today. Have other applications of these measures done a couple of things? One, provide any sense of what a meaningful difference between H primes are, and two, consider the sampling variability when you're measuring H primes or J primes to see which are statistically different from each other.
Yeah, those are very good questions in thinking about any kind of measurement field. On I'm not sure what the actual differences are and if there's published or if there's agreement among the literature about what those meaningful differences could be. I'd have to look at more work that's been done in this application.
Because you could bootstrap confidence intervals around your H prime and your J prime and, you know, get a sense of how much overlap are in those confidence intervals when you're comparing your 101 to your 5L to your 4L as one possibility. I'm done.
I think that's a good idea.
I think that's a good idea, too.
I hate Carter's question, but at least I have a good idea.
Dan?
Yeah, so the English language is imprecise. And it could be that with the 3L and 5L, probably more so with the 5L, if people are having difficulty, or not really difficulty, I think people have different understanding of what those subjective terms mean. And so that could be part of why there's some differences as you described. I think the issue with having a 101-point scale is that there's a lot of noise because people probably select things, you know, either in deciles or quartiles or something. You know, they select, they kind of round off their disability to certain levels. And so you're getting potentially, using the measures you're looking at, you're getting some noise because some levels aren't being used at all.
Mm-hmm.
Have you thought of combining the two, where you don't use so much language to describe disability? You still use numbers, but you only have 5 options, like a Likert scale. And you only ground it at the top and the bottom, and the rest are like 75, 50%, 25%.
So kind
of those extremes, that you're running into less language issues. Or do you think that would introduce other problems, like with people understanding proportions and, I mean, they do it already with
right.
with the 101-point scale.
Right, we're essentially just removing all of the little ticks that they could have chosen and just leaving the larger kind of response options.
Right.
Let me scroll back here if I can.
So my thought is that by doing that, you're going to remove some of the noise, and you may improve on what exactly the different levels are supposed to mean, as long as you're grounding the highest score and the lowest score appropriately. Then people will grade it in between.
Yeah, I think that's an option, and it could potentially remove some confusion or make the task easier. But I think one of the notable things with these Shannon indices that we saw is that for a lot of these dimensions, or like let's take a look at pain and discomfort, for example, the maximum J prime value is 1.0, which is because the denominator would be the maximum H prime based on using all of these 101 levels. So again, this kind of relates back to Todd's question of, is this meaningful that this is 0.72? I think it's at least partially an indication that people were utilizing to some degree those complete 101 levels that were offered to them, but maybe less so in something like self-care, right, where we see it's 0.37. But again, this relates back to, are these meaningful
It was low
values?
across the board for self-care.
Yeah.
I have a couple questions. This was a very nice presentation, by the way.
Thanks.
I've never heard of Shannon's indices either, but what about like item response theory? How does that relate to like brush modeling and item response theory, where with IRT, you know, it looks at utilization of each of the responses, and then it also looks for bias when you compare different groups. But then I don't know if you know, I don't know enough about IRT or Shannon's indices to compare those, do you?
Well, maybe not, but I can offer, I can offer what I do know, or some insight perhaps.
That sounds great, yeah.
Is that, you know, IRT methods are used heavily in the development of the EQ5D instruments. And there's a lot of research around using EQ5D or using rush modeling and other IRT methods with different EQ5D experiments. Yeah, I don't know.
So I guess
This is just a different sort of index that's unrelated to that sort of work that could be done with IRT, I guess.
yeah. Well, one application of this that to me seems obvious, and this is just to me though, because of the way I think, I would do an analysis looking at the individuals that completed face-to-face interviews versus the ones that did it online. I would want to know more about, I always do, their demographic characteristics. But, you know, you can get, as you pointed out, it could be that you don't know that those people that filled it out online are healthy.
Right. There's a degree of, like, the people that we're encountering out and about in the world could be different than those that complete online. And we did actually do that. We looked at it online. I didn't present it here because it wasn't that interesting. Overall, there was slightly lower VAS scores for each dimension and each level for the online only participants compared to the face-to-face. And like you said, maybe they do have really some more problems, but it could also just be like a social desirability thing that maybe people are more willing to rate themselves a little lower on the VAS when they're not being right next to an interviewer or something like that.
Yeah. I don't know. I would encourage you to at least mention that because to me, that's obvious. It's really important that the mode of administration, I mean, it's because in psychology, it's stress. So that would be something you might want to mention when you present, or you can wait and hope that they ask you the question because you got the answer in your pocket. In terms of looking at, like, the health status, do you look at that? I mean, I know you said that the health status you have is for lifetime health, and you just kind of talked through some of those things, but did you look at that and in some way try to analyze it related to this?
No, not yet. That's why I mentioned that as like the kind of last point is something that we had talked about and considered of how we can break this down into more ill or more healthy individuals.
I mean, I think you can't say this is not a patient population. You didn't recruit from within a healthcare setting.
Right.
Because we're all patients on some level, right? So I don't know. I guess I might have you think a little bit about how you talk about that, you know, that it's community dwelling or you recruited from the community. But with some of those folks that you do, I just always question anything online data collection because they could be cancer patients that do this to earn a little bit of money. I mean, you just don't know that much about them.
Yeah, that's a good point.
I don't know if it's a good point. But
no, I think it is.
You're being generous. I mean, it's just that I'm always thinking like, you don't know.
You want me to hate on Lisa's point?
Actually, Simon raised his hand. He may want to say something about this.
Simon, go ahead, if you're still there.
Oh, yeah, sure. I actually wanted to say something every time someone asked a question, but I'm glad that you were given the chance to respond. And I mean, these are great kind of reactions to your presentation, John. So these are points that we'll try to, between us, remember to list in your discussion and limitations. But I wanted to follow up primarily on Lisa's point, and just also why you framed it in the way you did. I think that the focus was on the measure itself and pointing out how it was originally operationalized was really in a basically qualitative rating scale calibration done in small groups in their response to different labels that they were presented with. And now we're looking at a way that we could try to see how appropriate those labels were. And the reason why John wanted to focus on this for the purposes of a population health measure is because you're quite right, Lisa, that everyone's a patient, but we were trying to think of how to best frame this, not to undermine the EQ5D enterprise and overgeneralize the implications of the results by pointing out that this was a general population sample, that it may or may not apply as well in terms of the way the EQ5D is operationalized, or these severity categories are perceived by people who have more experience with poor health than the general population. So it was more of a caveat about the generalizability at this point, and it may well generalize. And so these subgroup analyses, we could, that's a good point for future research. IRT, John pointed out, it's not entirely, the EQ5D is not particularly conducive to rash analysis because it's not a unidimensional construct. We know that the items do not load together well. So there's a lot of literature on that, and I've done a number of papers on this in the past if you're interested, though.
We are out of time. So thank you, everyone. Thank you, John.